better language to do this, and that is Glow. So I'm done with this thing, and I want to go to, I'm done with Chrome, and I want to get back, right here we are. All right, so this is the one I just got working today, more or less, as we're going to see. And I got interested in this because the number 3 cryptocurrency in the world is now Cardano. And Cardano is supposed to be very advanced and have a lot of new features. And Cardano is somehow associated with Glow. Although Glow just works on the Ethereum blockchain also, but I think it's intended to be part of the Cardano smart contract chain. Cardano is a new cryptocurrency, and their smart contract system is still in the process of being developed. But something I found there made me think they're going to use Glow. So you use Glow on a Debian 10 machine. So we're going to have a Debian 10 computer, and I've got one here. Let me just clear. All right. So you install Glow, which is incredibly simple. Just do an update, install curl, download this script, and run it. It's going to install it using some unusual package manager, which I haven't dealt with before. But anyway, you get this thing called Glow. And Glow Help will show you the commands of what you can do with Glow. So this lets you add contacts and run contracts. It lets you run smart contracts in a blockchain, and by default, it will connect to some online test blockchain. But when I tried it, that didn't seem to be working. You can also run a local blockchain and use it just locally, and that's how I wrote the project, because that worked fine. So this does not have a GUI, it's all command line, but it amounts to just the same thing we were doing in Remix. You run a local simulated blockchain and you practice with that, so you don't have to wait for time delays or pay any real money to use it. So we run the local Ethereum testnet here, and I've already got one going here. You just run Ethereum testnet. Then you create some identities which generate identity. You make one called Alice and one called Bob, and whenever you're using a local network, you add this --evm-network pet to the end of each command, and that will tell it to use the local simulated blockchain right on your Linux box instead of going on the internet and looking for a testnet. So then I will have identities, and I think I've already generated these identities because I was testing this project, but I can check that because I can see the identities in the blockchain this way, with just Glow list identities. There's only a few commands available here at the moment, so it's really pretty simple. It reminds me of the early days of Docker. Yep, so there we are. There's 2 identities, Alice and Bob, and these are their keys, those are their addresses. So I have 2 accounts, and I can move money from one account to the other to see how it goes, and that's what we're going to do. So they need to give them some money, and so you can give them money from a faucet. There is a Glow faucet that will put 5 in them. I'll just run the Glow faucet again because that's harmless. That'll give them a little more. I gave them 5 before, and then I transferred some around, so this will give Alice 5 more. And so here you see the transactions go by. This is just the kind of stuff you were seeing going by at the bottom of Remix before. So now she has 9 pets because she had 5, and I transferred 1. And now she got another 5. And Bob is where she transferred 1, so Bob should have a bigger number like 11. Yep, Bob has 11 pets. And there's some small change here from transaction fees and such. All right, so now they both got some Ether, and you can perform a transfer. This is how you perform a transfer from one account to another. It's really very nice. You don't even have to handle those long addresses. You can refer to these accounts by their nicknames, Alice and Bob. So this will do a transfer on my test network running on my local machine, moving from using Alice's database, because what I'm doing, you could use 2 machines, one for Alice and one for Bob, and then they would both have their own internal database keeping track of their transactions. But in this case, I have to tell it which database to use because I'm running 2 accounts on the same machine. So I draw from Alice's, and it's going to, from Alice to Bob, send 1 coin. And so it does. That transaction goes through, and then it shows you afterwards, now Alice is down to 9, and Bob is up to 12. Or Alice is down to 8, and Bob is up to 12, rounding these off to the nearest number. So now we're going to have the simplest kind of transaction. Alice is going to buy a signature from Bob. This is what you might do when you go to the notary to get a document notarized. Alice writes a document, and she says, I'll pay a token for you to sign this document. And they're going to do it on the blockchain. So what you do, you create a document, And then you create a digest of that document. This is how you always do digital transactions. So I put this string into a document called document.txt, and then I calculate a digest. Now you could in principle use this different hash functions, but here you use the Glow digest function, which is some kind of hash function. So it creates this digest, that long number. We're going to need that later. Now you deploy the contracts you have to the database, to the blockchain with this, and this will now ask you which of the available contracts you want to run. Glow start interaction using Alice's money on the test network. So now it's going to show me there are various contracts available, and the one I'm going to use is this one, a built-in demo contract called BuySig. I'm going to need this value here, so I'm going to copy that. All right, and now I just go through, okay, it's 1 for BuySig. They ask me, who are you? And I'm Alice. I am the buyer of a signature, so I choose 1 for that. The seller is Bob. And I'm going to use pets, the token. That's the tokens we're using. I don't know what those other tokens are. And now I put in the digest, which I copied earlier. That is the thing to be signed. And now I'm going to use a price of 1. And now the blocks are going by. I think it's 1 block every 15 seconds, like Ethereum usually is. So what happens is when you submit a transaction, I'm going to offer to Bob, hey Bob, I will pay you 1 token if you sign this thing. But what if Bob doesn't sign that thing? Then I give it a timeout. That's what this determines. And if that much time goes by and Bob doesn't sign it, then the transaction is canceled and I get my money back. So I could choose a time in the future. I find adding 100 to this is plenty of time to get things done. So 10861 is 100 blocks, so that would be 100 times 15 minutes. So that's like a half hour or something. So that's enough time that I don't have to worry about it. So now this is waiting for the seller to make a move. You have to leave this alone, and the seller has to execute these 2 commands to accept the transaction. So you have to have a second terminal open to your Linux box. So I've got one here. And so you copy this. This is a Glow start interaction agreement. What this is going to do is generate the thing that you're agreeing to. So paste that in here, but remember, you have to add some stuff to the end to be using the testnet. You have to be adding this EVM network pet stuff to the end, or it will try sending it off to a public blockchain testnet, which is not what we're using. So this is another terminal going to the same machine, setting up the transaction. Okay, and this is Bob. I choose 2 to be Bob, and my role is the seller. And now, to agree, I just have to paste in this handshake. That's the agreement. So Bob, if Bob agrees, he executes that command, and that should do it. Now Bob has agreed to do the signature, and now it's done. The price was 1. The signature has been put on the blockchain, and it appears here. And here's the buyer and the seller. So that is a transaction. All right, that's the game of a single transaction. And the code that, now remember we just saw, it was 300 lines of that JavaScript looking Solidity code to make the Ponzi scheme. This is the contract that does what we just did. That is the whole thing. They're really not kidding. I thought they must be hiding most of it until I found I could totally make one of these myself. That is the entire contract that does this. It is fantastic and wonderful. And here's the steps. So Alice is the buyer. You pay for a signature. You describe what's going on. I'll pay for a signature on this digest at this price. That describes the situation. You put that on the blockchain. Then you say, can you please sign this? Bob decides to sign it, creates the signed digest. Then he publishes. There is a publish issue here. In everything you make is private. Nobody can see it until you choose to publish it. Then people can see it. So he creates the digest. He publishes and verifies the signature. Then he withdraws the deposit. And this verification involves both people verifying it. So he has to verify that the signature is valid. And so the buyer, he doesn't get the money until the signature is verified to be valid. And if anything goes wrong here, it just times out and the buyer gets their money back. It's very nice. Instead of having many places where you move money around so you can make mistakes or happen in that contract, you just have one line doing each thing. So, 2, here you agree to this. This is where you define an interaction where both sides have agreed to participate in an exchange here. They both know what's going on. They both see that digest, which includes the information of what you're agreeing to, like a contract. Although you don't see that explicitly here. You will see it if you do the other projects. There's projects that show this atomic. This is an atomic exchange transaction, and if you want to see those, you will do multi-chain. If you do the multi-chain project, it's an older project that does this. You can see the joy of an atomic exchange transaction, which is what's going on here. You're agreeing to something, a whole contract. You get to read the whole contract before you agree. And that's very clear if you do the multi-chain project. Anyway, so now, here we do the digest of the message is the parameter, and here's the price. So you know the message you're trying to sign, and you know what price you're going to pay. So now the buyer deposits money. This does not go to the seller yet. It goes into sort of escrow. And other blockchains, I've seen them refer to this as freezing those tokens. Those tokens cannot be used for a while. That's why you set a time in the future. You promise not to touch those tokens for a certain period of time, so they're available in case the other person agrees. And this is also what happens on cryptocurrency exchanges and on real stock exchanges and futures and commodity exchanges. You make an offer, and you promise to keep the asset available for a while, and you guarantee it will be there. So that's what deposit does. Now you define this, let the signature be valid. The signature is sign of digest, and you define this as something that can be verified later with verifiably. Then you publish the signature so it's visible to everybody, and then you verify it. And it will not pass this step unless everybody verifies it. And then after you verify it, then the seller gets the money. That's the entire contract. And the point is you have only one line doing each job. There's nowhere else the money is handled. And everything you need is thought of here. So this handles all these failure cases. If the buyer never pays, let me make 2 copies of this. So I have one of these, and I can just, well, here, let's just, okay, right. Let me bring it up here. Let's bring up the contract. So if I go here, I can run Glow, help, and I can list contacts, or I can list applications. That's what I want. Let's Glow list applications. Okay, and here's the BySig application. It loads in some ridiculous long directory, but there it is, and I can just look at it. All right, there's the contract. They've added a few comments, but here's the point. So, all right, so if the buyer never pays, now they used this one line to do many steps, but in the original tutorial I went from, they had 3 separate lines here to do the, just calculate the signature, publish the signature, and verify the signature. Anyway, if the buyer never pays, if you ask someone to sign it but you don't pay for it, then what happens is you never do this deposit, and the contract never goes any further. So the seller will never perform any action, no money will ever find, it will all just time out and vanish after a while. So it handles that. Now if the buyer pays, but the seller chooses not to sign, just their machine is down or something, so that they never actually do this publishing the signature, never actually calculate the signature and publish it, then what happens is it stops at this point, and all it does is time out and give the money back to the person who requested it, so nobody loses anything. If the seller tries to send an invalid signature instead of a good one, then it will not pass this verification test. And when it doesn't, again, the seller will not get the money, it'll time out and the money, and will just go back to the person who sent it. And if the buyer never pays, we've already seen that one. All right, so that's the point. It handles all these nicely. All right. So that's what I wanted to show you. There is one nasty thing about this, which I haven't quite figured out. After what we just did, Alice paid Bob a coin to sign something. And I wondered what Alice's balance is. And I couldn't figure out how to get balance. But then I figured out if you do a transaction you can see the balance. That's why I added these transactions in here. So if I transfer from Alice to Bob a tiny amount of money, 0.01, it'll show me the balance. And as last time I remember, Alice had 8 and Bob had 12. So Alice just bought something for 1 coin. But Alice still has 8 and Bob still has 12. These contracts, which look so nice, don't actually work. And I found something in the documentation where he said, right now they're using test tokens, which we plan to change soon. This is all only a few months old. So I wondered why they didn't show us the balances changing. Right now, in this tutorial operation on this testnet, it doesn't seem to actually move the real coins you can see. So that's annoying. But I think it will change. This is all very new. But I got very happy about this, and I wanted to really show it to you, because this, I think, really is a much, much better way to write a contract. This will really address a lot of the vulnerabilities. And I've got other projects here, quite a few of them where you can practice other vulnerabilities, but I don't think it's worth demonstrating them. There's reentrancy, winning at an auction, a fallback function. There's various other things that go wrong due to this miserable solidity function. And I think the point is this Glow stuff is just a more secure language, like Rust is. Rust is a more secure replacement of C, and Glow is a more secure replacement of Solidity. And I think this is a really exciting, good thing in the world of computing, is to move to these more secure programming languages that will hopefully not have so many pitfalls. So that's what I wanted to show you.